Hi everybody, this video is going to cover section 3.1, which is on systems of equations. Yours might look a little bit different up here. This is unit 3 and this is 3.1. We're going to be talking about solving systems today. You have already solved systems before, so I'm going to go maybe a little bit more quickly, and if you need extra practice, I will make a second video that would be an optional video. But let's go ahead and get started. Our first method that we're going to talk about today is substitution. We all know the meaning of the word substitution. It means when you take something out and you put something else back in. And the problem with some people is they forget to take the thing out. So make sure you're taking something out when you're doing your substituting. Well, I have two examples here, but they are different types of examples. If we look at the first example, this example, one of them is already solved for y, whereas in example B, they are both already solved for y. And I just bring that up because there is a slightly different way to approach each problem. Let's start with example A. All right, getting back to that concept of substitution. If I have y and y is equal to 2x plus 10, that means I can take out the y out of the other equation and put in 2x plus 10. And so that's what I'm going to do. I'm going to take out that y and plug in 2x plus 10. Okay, now I need to solve this equation and find out what my x value is going to be. Okay, well, I combine my like terms. 2x minus 4x is negative 2x. I bring down my plus 10. I bring down my equals negative 8. And I'm going to keep on going here. So I'm going to subtract 10 from both sides. So I divide by negative 2, and I get x equals 9. And that is a positive 9, and it's important to keep those positive and negative signs all straightened out, because when you plug it back in, then you can start to make some mistakes. Because that's our next step, right? When we do a substitution, we found the x, but we need to find the y. Well, we're going to do another substitution. This time, we're going to take the number we just came up with, that's 9, and we're going to plug it in for x. We can use either equation. I think that bottom equation is going to make more sense because it already says y equals. So that'll be easier to plug in. And so I'm going to come over here. I need to make a little space for myself. I'm going to come over here and I'm going to plug in the 9. So I get 2 times 9 plus 10. Y equals 2 times 9 plus 10. So that means y equals 18 plus 10. And so we get our final answer to be 28. Remember that what we are actually doing is we are seeing where will these lines hit each other. We haven't really talked about graphs in this unit yet, but that's what we're determining is if we graph these lines, where would they hit? And here's the place where they're going to hit. So when I give my solution, I have to give my solution as a coordinate. And so my final answer is 928. If I graph them, that's where they would hit each other. Now, it's always a good idea to plug back in and check your answer. You can do that with a calculator, or sometimes you can do it in your head. This might be kind of too big to do in your head, but let's see. So we already kind of did the bottom one. 2 times 9 is 18, plus 10 is 28. We got that. Let's check in the top one. 28 minus 4 times 9. Okay, what's 4 times 9? 4 times 9 is 36. So 28 minus 36, does that equal negative 8? Yes, it does. So that does work out. It's just a good idea to practice both of the equations, solving both the equations, plugging them back in to check your answer. All right, let's take a look at example B. I mentioned before that example B, we're going to set it up a little bit differently. It's a little bit confusing to some people. I actually think it's a little bit easier, but let's take a look. So remember that we're going to look at, what does y equal, and then plug that in for the other y. Well, both of these equations are already solved for y, so if y equals 2x plus 2, we could plug that 2x plus 2 over here. Or you could do it the other way on the top one. But let's go ahead and write out what we have. So either way you do it, you could say 2x plus 2 is equal to negative 3x plus 4, or you could say negative 3x plus 4 is equal to 2x plus 2. Either way. I just need to solve these equations now, so I'm going to add 3x to both sides. Next step is going to be subtract 2 from both sides. Okay, I came up with a fraction answer. You know what? That's okay. and we need to start to become comfortable with fractions because we will have quite a few fractions. 2/5 is a totally valid answer. Let's go on to our next step. So remember that the next thing to do is to take that x value and plug it back in and solve it for the y value. You can plug it into either the top equation or the bottom equation, does not matter which one. Sometimes you might want to pick the easier one. Like, I wish one of these had a 5 in the coefficient, but it doesn't, because if it had a 5, it would cancel out. So I'm just going to pick the top one. A lot of times people pick one that doesn't have negatives in it, because that is just another place you can make a mistake. So let's try that top one. Okay, again, we are going to have a fraction, and we need to become familiar with fractions and comfortable with fractions. Fractions are our friends, so we're going to give it a try. When we do fractions, 2 times 2/5, we multiply the numerators together, and we multiply the denominator. Well, the denominator was 1, so that gives me 4/5. The 2, I need it in terms of fifths, so the equivalent in terms of fifths would be 10/5. Now I'm going to add those two together. Because they're common denominators, I had to do that to make a common denominator. In this class, do not give me a mixed number. Mixed numbers are not appropriate at all for algebra. They're for middle school and elementary school. So we add these together and we get 14/5. Okay, so this time our final answer, it has fractions in it. That's a little scary. It's okay. This answer is going to be 2/5 and 14/5. That is the final answer. We can check it. We kind of checked the numerator a second ago right here. So let's go ahead and look at the denominator. If I multiply -3 times 2/5, I'm going to have to show some scratch work. That's going to give me a -6/5. And I'm going to add 4. Well, that makes 20/5. 4 is 20/5. And then I add that, and I do get 14/5. We got the right answer. It's a fraction. It's messy, but it's okay. That is how you do substitution. The next thing we're going to do is take a look at some elimination problems. I call this elimination method, but quite honestly, another name for it is linear combination. And so sometimes I'll use this phrase combine. That's linear combination. They are the same thing. If you get confused with those two words, they're the same thing. When we do elimination method, this is the one where we are trying to add these two equations together, combine them, linear combination, and when we add them together, we then solve it from there. Okay, but you want to start, before you combine the equations, you have to either get the x coefficients or the y coefficients to be opposite numbers. Now, what do I mean by that? What I mean by that is we kind of need them to match up. For instance, I'm looking at example A. 3 and -5, they do not match up. 6 and -2, they do not match up. But what I could do is I could multiply this bottom one times 3. So I'm just going to rewrite the top one. I'm not changing that at all. I'm keeping that the way it is. But on the bottom one, I'm going to multiply it by 3, so I get a -15x minus 6y is equal to -42. Don't be afraid to use your calculator. If you have to use your calculator, that's totally fine. So now, look what I did. I got the 6 y's to match up. What I'm saying is, over here, they are opposite numbers. They're both 6, but one's +6, one -6, and they're both on the y values. Now that I've done that, I can add these two equations together. And so I get a -12x, this cancels off, and I get a -48. I'm going to divide by -12, and I'm going to get my final answer. Well, I said final answer. I got the x value of the answer. All of these equations, systems will have an x and a y part to their answers. So we found the x, we need to find the y. How do we do that? Well, we plug that x back in. You can plug it into either one. Does not matter. But it should be one of the originals, not one of your ones over here, one of your originals. So I might just pick the bottom one just because. Actually, you know what? A lot of people would probably pick the top one because there's no negatives. Let's stick with that. So I'm going to take that 4 and I'm going to plug it in for the x. So 3 times 4 plus 6y is equal to negative 6. That gives me 12 plus 6y. I'm going to subtract that 12 from both sides, divide by 6, and I get negative 3. And so my solution, once again, my answer has to be as a coordinate. So my final answer is 4, negative 3. Once again, we should check that. We came up with this part from the top equation, so maybe let's pick the bottom equation. I'm going to plug it in with my calculator or in my head. I'm going to take a 4, that gives me a negative 20. I'm going to take this and gives me a positive 6. Negative 20, positive 6 is negative 14. I did it right. This is the solution. And just to remind you, what this is doing is showing us the intersection point. If I graph these two lines, where will they hit each other? Here's where they're going to hit. Problem number 2b is very similar, and it's going to be one that I'm going to save for the additional video. If you still need more help, you can watch the other video on how to do problem 2b. To wrap it up, I have a couple of questions here. When would substitution be easier? When would elimination be easier? Do you remember talking about no solution in previous years? What would that look like if you had no solution? What would the equation look like? What would the graph look like? And what about infinite solutions? What does it look like when you have infinite solutions? As far as an equation, as far as a graph, what does infinite solutions look like? What I want you to do is take some time to think about these and answer these, and when we come to class next time, you'll give me those answers. There is one more problem we need to do, but I'm going to make that a separate video. So we're going to do the back page on a different video.